Hello everyone, in this video what we are going to do is we are going to start with the analysis and design of our staircase, two-flight staircase using SAP 2000. So the first thing we are going to do is we are going to go to File, New Model, and we are going to select our units to be in kilonewton meters and select the blank option. So now let's close one of our windows. Right click here and edit grid data, modify. Now let's add one option for every direction, X, Y, and Z. Our display grid is going to be spaces between them, and in order to know the values that I'm going to input along the X, Y, and Z, we're going to go to this image here. So along the x-axis we see that we have 1.5 meters which is my landing, then 2.7 meters which is my flight, and then another 1.5 meter which is my landing. And along the y I have 1.5 meters, 0.5 and 1.5. Now when it comes to my Z, I'm going to take it as my floor height, which is going to be 1.5 meters. So let's go back to SAP, add. It's going to be 1.5, 2.7, 1.5. We always end with 0. Same here. 1.5, 0.5, and 1.5, just to make sure it's 0.5, yes. And here it's going to be 1.5. I'm going to add two floors, 1.5 and 0 here. Okay, and okay. So now we can see our grid data. Let's go to the XY direction here. Okay, let's go to define materials, add a new material. Our region is going to be Europe. Our material type concrete, and our grade we are going to select it to be 25, 30, 25 usually for cylinders and 34 cubes. So okay, now go to define again, section property frame section, which is my beam. Add new property. My beam is made up of concrete. It's a rectangular section. We're going to call it drop beam 20 by 50. So let's just make it in capital letters. My depth is 0.5 meters, my width is 0.2 meters, and my material is C25, C30. Okay, now define section properties. My area section, which is my shell, we're going to call it slab 27 centimeter thickness, so we are going to have 0.27 here and 0.27 here. Okay, and my material name again, it's C25, C30. Okay, and okay. So now we are going to go add my load patterns, which are going to be dead, live, which is type live, add and superimpose dead load, which is type super dead. Now we can't find it here, so just press on more and select super dead, add new pattern. Okay, now again define this time our load combinations. We're going to have two load combinations, one which is 1.2 dead load plus 1.6 live load. This is for the design combination that we are going to use, which is going to be 1.2 dead and 1.2 superimposed and 1.6 live. Okay, and add new combo. This is going to be for my serviceability check, basically checking for my deflection. I'm going to use this load combination, so it's dead, live, and superimpose that load. Okay, so now what we are going to do is we are going to start drawing my slabs here. So let's go here, quick draw area. It's going to be my SS27. Just right click on this area here and it will automatically draw it for you. So You can see how it's working here. Now, if we go to set display options, general options, let's check that our fill objects option is checked. Apply. Okay. Now, this way we can see our slabs more clearly. Now we can go to 3D and look at our model. So what we are going to do, this is my landing, this is my flight, and this is my landing. So we know here that my flight is basically here and here. I do not have anything within this area. So let's just go to view and remove my grid for me to better see this option here. Let's select these three slabs, delete them, and let's select these three and edit them, move them up at a distance of 1.5 meters. Okay, so here, because this is my landing, my flight is going to be here, then I have a landing, then I have another flight. So we are going to select these three and replicate them at a distance z equals to 3 meters. So edit, replicate this time, dz3, apply. So now we can get or we have a better image of how my stairs is going to look like. So now I need to draw my flight. So go here and just select from here to here to here to here and then press enter. Okay, wait, just let me repeat it. Okay, from here to here to here to here, enter. Okay, now the same thing. Now if you want to rotate, you simply press shift and you scroll using your middle button. So same thing here, select from here to here to here to here and press enter. So now we can see that, or we have a much better image of our staircase or our model for our staircase. We can see our landing, we see our flight, our landing, our flight, and our landing. So let's just untick my local axis. Okay, so now that we are done with this, we said that we have supports at the corner. We have a support here, a support here, a support here, and a support here. So let's just select my corner points now and assign my supports, which are going to represent, they're going to represent my beams, which are going to transfer my loads to my columns. So these are going to be my columns. I'm going to assign joint restraints. They're going to be pinned, apply. Okay, we can see our supports here now. Now what we are going to do is we are going to draw our beams. So to draw our beams, we're just going to go here, draw a frame cable, which is going to be a straight frame from here to here, enter, from here to here, enter, and finally from here to here, enter. Okay. So now we see that we have our beams. Drop beam 20 by 50. We were able to draw our beams. So now we have our beams, we have our supports. So let's just go here and show my restraints. Apply. Okay. Okay. So we have our beams, we have our slabs, and we have our supports. Now, the next step is just, let's go to view, set 3D view, XY, or before that, let's just assign my loads, the loads that are going to be applied on my slab. So we go to assign, second. Okay, so we go to select, properties, area sections. It's going to be my SS27, close, assign area loads, a uniform load. My uniform load is going to be dead load of 3.5. Okay, it's going to be gravity, not gravity projected. So just select previously selected and replace existing loads. Okay. Now we are going to go to live. My live is going to be gravity projected. So basically it's perpendicular to my x-axis. So this is 5. Replace. Now select your previous selection and apply. So now we have assigned my live load and my superimposed dead load. So okay, let's just double check here. Okay, gravity and previously selected. Okay, okay, now we can go here, and my next step is to select again previous selection, select my slabs, and then go to edit areas, divide areas. So I want to divide my areas here into mesh. So to do that, this is for us to be able to read our results. So we have a divide area into the number of objects, so the number of mesh you want along this direction and this direction. Let's say you want 6 by 10, so it's 1 2 3 4 5 6, let's say, and 10 along this direction. Or if you want to divide your meshes according to a specific size, so let's start off by dividing them to a size of 0.25 meters. Okay, we can see that we have assigned our meshes. Okay, so now just to double check, I have assigned a dead load of, just go here, I've assigned a dead load of 3.5 kPa along my slab, which is not what I was supposed to do. So let's just get my previous selection here. Okay, just select by properties, area sections, my SS27, instead of assign now area loads uniform. So let's just go to that and assign 0 kilonewtons per meter squared and replace my existing loads, because I do not want a dead load. My 3.5 kPa is a superimposed dead load, it's not a dead load. So just to double check, I have assigned it as a dead load by mistake. So we should select it as 0 kilonewtons per meter squared. Now in order for you to see the dead loads that you have assigned, go to display, then go to show object loads assigned and go to area, and this way you can see the loads that you have applied. You can see here that you do not have any dead load now. You have a live load of 4.37 because it's gravity projected, it's 5 here, and a superimposed dead load of 3.5 because it is gravity, so you can see it's 3.5 all throughout. However, my live load along my flight changes to 4.7, so as it is gravity projected. So close, show on the form shape. Now go to view, set 3D view. Now go for XY. My aperture is going to be 0. Apply. Okay. Now, if you notice one thing here, we can see that our nodes are not coherent, or basically my nodes are not connected to one another the way they're supposed to be. So this can actually cause errors in my results. While I'm reading my results, I'm going to get inaccurate results to a certain extent. So what I need to do is I need to make these nodes coherent or intersecting at this point. How am I going to do that? I'm going to go to my 3D. Okay. I'm going to select these meshes here. So let's just go here. Okay. And remove my mesh area. Now pay attention, because I removed my load assignment, my dead load assignment. So let's go to display and go to show load object load assigns area and check if I have a dead load. Yes, I do have a dead load. So let's just remove it again. Select by properties, area sections as select. Okay, now assign area loads uniform, go to dead and select 0, replace. Okay, now the first thing we are going to do here is we are going to select the areas that are equal to each other, which are these areas in my landing slab, and I'm going to go to edit areas, divide, and divide them to an area of 0.25 meters. Now the second thing I'm going to do is I'm going to select my flights, and I'm going to divide the areas here according to the number of meshes that I require. So if I look here, I require 1, 2, 3, 4, 5, 6 meshes along this side here. So along this side, which is point 1 to 3, I'm going to require 6 meshes. And along this side here, let's select 10 meshes because it's a long distance, and apply. So we can see here that we have 1, 2, 3, 4, 5, 6 meshes along, and 10 meshes here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 meshes. Now we're going to do the same thing here for this, and this. However, this time we want 6 meshes along this direction. 1, 2, 3, 4, 5, 6. So yeah, 6 meshes along this direction, and we can place 2 meshes along this direction because I don't think we need more than that. So now the 6 is along this direction, so this is 6 and this is 2. Apply, and we see that everything is now working. I have coherent nodes. I will not have any issues when it comes to my uh, to reading my results. So now that I am done with checking my mesh, checking that my nodes are coherent, they are intersecting, I'm going to close this or press OK. Now the next step for me to do is to check that my axis is moving along the right direction. So basically what I'm saying here is, let's say I have direction 1 moving parallel to the x-axis, direction 2 moving here, and direction 3 along the z-axis. Here I should have direction 1 moving along the x. Same for my flight, I should have direction 1 here and direction 1 here. Because this way, when I'm reading my results, I have to read M11, M11 here, M11 here, and M11 here to check my moment that is being applied in this direction. However, if I have my direction 1 moving along this direction, and here I have my direction 2 moving here, then I have to read M11 here, and then I have to read M22 here, and then I have to read M11 here again, which is going to complicate the procedure. It will make it complicated, it will not make it convenient, and this is what we want to try to avoid. So to do that, we are just going to go to set display option, show my local axis, press OK. So we can see here direction 1 in red, direction 2 in green, and 3 in blue. We can see here that my direction 1 is going along the x-axis. However, here my direction 2 is what's moving along the x-axis. So this is what we just said. This is not convenient for us while reading my results. It will not produce accurate results. When I'm reading M11, my results are correct here and here. However, here I have to read M22, which is not convenient for me. So what I'm going to do is I'm going to go back here to edit or view, set 3D view XY, and put it as 0 here. Okay, and I'm going to select this area here, this area. Okay, I'm going to assign area local axis. I'm going to rotate it 90-degree angle. This way I have my x, or my direction 1 along the x axis. Now the same thing here, but here we have to rotate it at an angle of negative 90 degrees. So again, we can see direction 1, direction 1, and direction 1. This will not cause any issues now when it comes to reading my results. I have to read M11 and I will find the results for all of my slabs, whether it was my landing, my flight, or my other landing. So we can close this now. We can go back to 3D view and we can turn off my local axis. Now I'm going to select apply. Okay, it did not turn off. It's okay. So let's just select all of my model, go to edit, replicate this model. Let's replicate it at distance 10 dx and 3 dz. Now, why are we replicating our model? Because we want one model for us to work with our serviceability conditions, and the other model we are going to use it to check for our design conditions. So one to check for deflection, the other to check for design. So let's start with this. So let's go to select properties, frame sections, my beam. Okay, right click, show selected objects only, select these beams here, which are going to be my SLS state, serviceability limit, and I'm going to go to assign, frame, property modifiers. I'm going to add a property modifier 0.5 for my SLS, apply, and for this I'm going to add a 0.35 for my design. Okay. Now we can close, show all objects. Now go back to select by properties, area sections, my slab. Okay. Now assign, we are going to show selected objects only, select my SLS. Okay, assign area stiffness, and it's going to be 0.35 here and 0.25 for my design. So this is 0.35, and select all of this here, assign area stiffness modifier and 0.25. Okay, now we can do this and show all. Now we go to analyze, set analysis objects. Okay, it's in 3D. Now we are going to go to analyze, set load cases to run. We want our dead to run, live to run, superimpose dead load to run. However, my model, I do not want it to run, so it's only these three options, and I can now run my model. Okay, let's just save it as to flight staircase. Save. Okay, so now we have our results. First of all, we said we're going to check for my deflection. So this is my deflection model. Go to show deformed shape, dead load plus live load. This is the case we are going to use. Draw contour along UZ and apply. Okay, now close this. We can go here and read our results. Our results are in meters. Let's change our results to millimeters. So go here, change our results to Newton millimeter. Now the allowable deflection that I have is going to be the length here over 240. Now the length here, we calculated it before. It was 6.11, so 6.11 divided by 240 is going to give me an allowable deflection of 2.5 centimeters. So if I look here, my U3 is 17 millimeters, which is 1.7 centimeters. It is acceptable. So if you look here, you have 16. So yeah, my max deflection is 17 around this area here, which is what's expected. Now, what this means is that I have a leeway to reduce the thickness of my slab. So I can just unlock, okay, go to define section, area sections, modify. Now pay attention, because we let's change it to 25. We changed our units to Newton millimeters. My thickness is now in millimeters. So pay attention to that. We will not input our values as 0.20 or 0.25. We will input them now as 250 millimeters. So this is a very important point, because when we're reading our results, we set our units to Newton millimeter, and this changes the units here as well. It doesn't only change the unit of our readings. Okay, now press OK, and run again. Let's check our deflection if it was okay or not. So let's go here, apply this, and let's see. Now our deflection is 20 centimeters, which is still okay. So a thickness of 25 centimeters is good enough to satisfy my deflection requirement. So now that we are done with my deflection requirement, my next step is to check for my design. Okay, so to check for my design, what I'm going to do is I'm going to go here, select shells. My case combo is 1.2 dead load plus 1.6 live load. I'm going to check my M11, and my M11 is going to be my major moment because it's along this direction here. So this is, I expect my M11 to be my major moment, and we can see, okay, let's just change the units again to kilonewtons meter. Okay, so we see that my moment is 101 kilonewtons per meter squared. Yes, so my max value is around 101. Now, why don't we look here at min and max? Because we have two models, one for SLS and one for ULS, or one for design and one for serviceability conditions. So this is taking into consideration both models. So it's not accurate to read our results here. It's accurate to just check our results along my flight and landing. So if we look at my landing, my moment is significantly less than the moment along my flight, which is what's expected. I'm going to have max moment around this area here, which is around 101 kilonewtons per meter squared. Now if I check M22, my M22 is going to be my minor moment, and yes, it is, because the values are so small. They're around 3, 4, 5 kilonewtons per meter squared. So let's go back to M11. We said our value is around 101 point, let's say 3. So what are we going to do with this number here? We are going to go back here, and we are going to use my fireman equation, which is basically fireman equals phi area steel Fy to d minus a over 2. Now just go here, just select this, delete this. Okay. Now, second equation, to find a, I'm going to use 0.85 f prime c times b times a equals a s f y. So here I'm going to find a in terms of as, and I'm going to substitute it in this formula. So it's going to be a equals ASFY over 0.85 f prime c times b, which is basically equals to Fy is 420, as we want to find it later, over 0.85 f prime c is 25 times b, which is 1000, because we said we are reinforcing per meter. So this will give us, implies a equals 0.02 as. Now if we substitute this value in the equation above, I'm going to get 0.02 9, which is my phi, times Mn, which is 101, equals 0.9 times AS times 420 times D. My D is 250. If we take a cover of 25, we subtract 250 minus 25, so my D is going to become 225 millimeters. So 225 minus A over 2, which is 0.02 AS over 2, so it's 0.01 AS. So implies what I will get, the final answer I will get implies this will cancel with this, and to change this value here to millimeter to Newton millimeter, I need to multiply it by 10 to the power of 6. So it's 101 times 10 to the power of 6. So this will give me AS equals 1244 millimeters squared per meter. Now, if I'm using a Tor 16 reinforcement or rebar of diameter 16, if I want to find the number of bars, it's going to be 1244 divided by 200, which will give me 7 bars, so it's 7 Tor 16 millimeter. And if I want to find the spacing, my spacing is going to be 1000 over 7 minus 1. So this 7 Tor 16 millimeters, where am I going to distribute this reinforcement that I just found? So if we go to this image here, this shows us the detailing of the reinforcement we just found. You can see that all of this reinforcement is used to cover the positive moment. So here we have reinforcement from here to here all the way up, and a reinforcement here. So it's from landing up to flight and then back to landing, placed along the length of my stairs. So if we go back to this image here, what's going to happen is I'm going to be placing my reinforcement here, and I'm going to distribute it as a spacing as, so one reinforcement here, another one here next to it at spacing as, along the width of my staircase. So this is basically how you reinforce for your staircase. You just find the moment that is being applied at your staircase, find the area of steel from your moment using the Feynman equation, the capacity rule, and then translate it into the number of reinforcement required according to what reinforcement you are going to use. And we saw the detailing of how are we going to distribute our reinforcement. So this is it for our first example, which is 2-flight staircase. In our next lecture, we are going to start with our second example, which is a 3-flight staircase. I'll see you then.